Hello. We just found the greatest common factor of 12 and 18. It was 6. We have 2 more examples. This is where we need to end up. And so those of you that might be able to do the greatest common factor work in your heads for just plain numbers, learning the process on the problems, the number ones, even if you know the answer right away, is important because we are going to need to be able to use that process when we add in variables. So this is our end goal. So let's do one more example and then we'll try one of those algebra ones. Because really we've worked on greatest common factors in the 6th grade and in the 5th grade. So now that we're in pre-algebra, in the 7th grade we have the variables is what's new. So we're going to start by breaking down these numbers. Excuse me. You can take any common factor. Any factors of 36 that you can think of. Maybe right off the top of your head, you think 12 and 3, or 6 and 6, or 9 and 4. There's so many places to start. It doesn't matter where. I just start with the 2 that I can think of right away. And for 36, I think of 6 and 6. And then I can break 6 down. They're both not prime, to 2 and 3. And 2 and 3 are both prime numbers. And this 6 breaks down into 2 and 3. There are no more branches that are composite numbers, so then I can write it out. 36 is 2 2s and 2 3s. Now I can do 54. 54 can break down a lot of ways, but I immediately think of 9 and 6. 9 is composite. It breaks down into 3 and 3. And 6 breaks down into 2 and 3. They're all prime, and so I know I'm done factorized, like using the prime factorization. So 54 is 1 2 and 3 3s. Again, you can check to make sure you have the prime factorization correct by multiplying 2 times 2 times 3 times 3 on your calculator, and you'll get 36, which is the coolest part. Then after you have these, then you're going to look for the common factors, the things that they share, because I'm trying to find the biggest common factor. So I'm going to find the little common factors and multiply them together. So they have a pair of 2s and then 2 pairs of 3s. And so to find the GCF, I'm going to take one number from each group. I'm going to take a 2, a 3 from this group, and a 3 from this group, and then I multiply. 2 times 3 is 6. 6 times 3 is 18. So the greatest common factor is 18. 18 is the biggest number that goes into both 36 and 54. One last example, and this is where variables get involved. We're going to start by making the prime factorization of each of the numbers. The numbers here, would be 3 and 3 for the 9. So 9x squared y to the third. The 9 is 3 times 3. And then what x squared means is I'm multiplying 2 x's together. So x squared means x times x. And y to the third means y times y times y. Then I have to do my 6. 6 is 2 and 3. So 6x to the fourth y squared would be 2 times 3. X to the fourth means 4 x's. X, 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 x. Y squared means 2 y's. After you have those all written out, you're going to find the common ones. They have a 3 in common. 1, 2 x's. There's no more x's up here, so there's no more. And then 2 y's. 1, 2. And then to find the GCF, I'm going to take one of everything. A 3, an x, a y, and a y. Because I have 2 groups of x's. And then I can just combine the variables. 3, x squared, y squared. That's my GCF. Thank you. We'll practice a lot.